Okay, the following is a video over 2-6 notes, and this is continuity. Basically, what continuity means, and here's how I think of it, you have to say, can I draw the graph without lifting the pencil? Graph, draw the graph without lifting the pencil. Okay. You've probably heard of us talk about continuity, the continuous function or discontinuous. So let's think about something that would create a discontinuity. So a discontinuity, all right, would be either a hole, that's a discontinuity, a jump, okay, slash break in a graph, and then vertical asymptotes, okay, create discontinuities. All right, so by definition, we need to think about what it is to have a continuous function at a point. Okay, so I'm just going to draw an arbitrary x and y axes. I'm going to label this as my x-axis, my y-axis, and I'm going to come here. Okay, I'm going to put a point B, and I'm going to put a point C. Okay. And so, actually, instead of that, I'm going to use actual numbers. I'm going to use 1 and 2. All right, I'm going to say 1 and 2. Okay, at 1, I have a point on the graph. I'm going to make my function like this. Okay, just some arbitrary function. And I'm going to make this be the point 2, and this is the point 1, and I'm going to put a point here. Okay, so what I want to do, we're continuous everywhere, but we're concerned about what's happening at 1 and what's happening at 2. Okay, and so here's what I want to do. I want to ask this question. Okay, what's my function value? Okay, what's my function value? And when I say that, I'm asking for what is the point on the graph? What is the point on the graph? Okay. And so my function value at f of 1 is equal to 2. Okay, so now let's also take the limit as x approaches 1. So the limit as x approaches 1 of f of x. And that value, as I approach from the left and from the right, okay, we actually get 2. Okay, because these are the same, okay, my function, f of x, is continuous at x equals 1. Okay, now let's take a look at x equals 2. All right, so let's find f of 2. Okay, well, my function, my point on the graph is at 1. Okay, and let's take the limit as x approaches 2 of f of x. And if I do that, I'm going to go ahead and just say that I get 2 as well. Okay, so what you'll notice here, guys, is that my limit exists, okay, at x equals 2, but it's not the same as my function value. So these are different. Okay, they're different. So this is not continuous at x equals 2. Okay, and I have to use the function value and the limit value to show that. Okay, so let's just go ahead and take a look at problem number 12, and it says determine the points at which the functions have discontinuities. Okay, and for each point, state what conditions in the continuity checklist that are violated. And this is our checklist, function value and limit value. Okay, so I see that we have a jump here at x equals 2. So I'm going to write this. At x equals 2, let's find our function value. Okay, I know that f of 2 is equal to 2. Okay, that's where my point is. And then let's take, what's the limit as x approaches 2 of f of x? What's that equal to? Well, that doesn't exist. Okay, there's a break in this graph, so this does not exist. Okay, so I need to make that claim that the function value is 2, but my limit doesn't exist. In order for this to be continuous, my function value has got to equal my limit value. Because these are not the same, it's not going to work. Okay, let's take a look at x equals 3. Okay, at x equals 3. Okay, what's my, and we have a vertical asymptote at x equals 3. Okay, so let's find, what is f of 3? Well, that's undefined. Okay, it's undefined. Okay, and let's take the limit as x approaches 3 of f of x, which gives us a it gives us negative infinity. So limit as x approaches 3 of f of x goes to negative infinity. Okay, so because undefined is not the same as negative infinity, this is not continuous at 3. Okay, let's try at x equals 4. Okay, so at x equals 4, all right, my function value, f of 4, is equal to, what is that, 2? F of 4 is equal to 2. Now let's take the limit as x approaches 4 of f of x. And so as I approach 4 from the left, I'm approaching 4, a y value of 4 is approaching right, approaching a y value of 4. So these are two different things, okay? Because these aren't the same, we're discontinuous at those values, okay? All right, let's take a look at number 14. It says determine whether the following functions are continuous at the value for a. Okay, then use the continuity checklist to justify your answer. So here's what I'm going to do. I'm going to plug in f of negative 5. Okay, if I plug in negative 5, I get 2 times negative 5 squared plus 3 times negative 5 plus 1 all over negative 5 squared plus 5 times negative 5. Okay, so I end up getting, well, here's what I notice in my denominator. I notice in my denominator, I get 25 minus 25, which gives me a 0 in my denominator. So this is undefined. Okay, so automatically, if my function is undefined, then I don't really have to do anything. I just know that it's not continuous at 5. Okay, and the limit actually, well, at the and that's okay. So what's happening here at x equals negative 5? Okay, at x equals negative 5, that's a vertical asymptote. Okay, that's the first thing I would check. Okay, if you need to first make sure that you have a point on the graph. Okay, if you have a point, find the point, and then find the limit. And if those are the same, then you're continuous. Okay, let's take a look at number 18. Okay, and first thing I want to do is I want to find, okay, well, what's f of 3? Okay, we've got this piecewise function here. The function exists for all these values except when x is equal to 3. Okay, when x is 3, we get a y value of 2. So at f of 3, we get 2. Okay, so now I want to take the limit of this top part. And if I find the limit as x approaches 3 of x squared minus 4x plus 3 all over x minus 3, okay, if I plug 3 in, we're indeterminate. Okay, so let's rewrite this. Let's say the limit as x approaches 3, let me factor my numerator into x minus 1 times x minus 3, okay, all over x minus 3, all right? And so what I see here is that the factor of x minus 3 divides out, and we now have a limit as x approaches 3 of x minus 1. And if I plug in 3, I get 3 minus 1, which is equal to 2. Folks, my limit value and my function value are the same, okay? So we are continuous at x equals 3, okay? And that's the test, okay? Are these things the same number, okay? All right, let's take a look at number 51. Now, this is a little tricky. I would use your graphing calculator to kind of evaluate this. And what you've got is the function cosecant of x. And I'm just going to graph this real quick. And what I know about this function cosecant is that every time I go around the circle, halfway around the circle, not 2 pi, just 1 pi, my function is undefined, okay? And so let me do that at 2 pi, and I have vertical asymptotes, okay? And the cosecant graph does this, where you get the U shape, and it alternates between the two, okay? And so then what I want to do is, it's continuous for all values except at pi, 2 pi, this next one would be 3 pi, 4 pi, and so on. Okay, but let's evaluate these limits. We want the limit as x approaches pi over 4 of cosecant of x. Okay, let's see if these limits exist. Well, pi over 4 is right here. okay? And so if I plug that in, I get cosecant of pi over 4, which is 1 over sine of pi over 4. So I end up getting this. I get 1 over, sorry, not 1 over, yeah, 1 over, sorry, root 2 over 2. And then that's the same as me doing 2 over square root of 2. If I rationalize that denominator, then I end up just getting 2 root 2 all over 2, which ends up just giving me square root of 2. Okay, so that's my limit value. Now I know it's not, I know it's continuous there. So the only places where it's not continuous is at pi, 2 pi, 3 pi, and 3 pi. All right, so then the last one is what's the limit as x approaches 2 pi from the left of cosecant. As we approach 2 pi from the left, we're approaching negative infinity. So guys, I want to make sure that, you know, I go back and watch this, make sure you understand what's going on. This is pretty important. When you know that you have a continuous function, we kind of need to know what that looks like. But go ahead and get started on the notes, and please get started on the homework.